Okay, so let's talk about the scientific foundations of psychology. So, first of all, why do we need to understand the scientific foundations? So that is because humans make mistakes, right? They aren't perfect, they make errors and they have biases. And one of those biases is hindsight bias. So hindsight bias is when something happens, it seems inevitable. And people often say, oh, yeah, I knew it all along. And an example of hindsight bias is when there was a study where people had to unscramble jumbled up words. Oh, whoa, hold up. There we go. Okay, so example is when there was a study um, where people had to unscramble jumbled up words. And once they saw the words unscramble, they were like, oh, yeah, of course, we knew it. Hindsight bias made them think they knew it all along and that the task was actually easy and that they could have just figured it out if they had a couple more minutes. When in reality, they probably wouldn't have figured it out until, for a long time. And then we have overconfidence. So people are actually more confident than we are actually correct. So there was a study where people were taking a test and they were often 99% more certain that their answers were correct than but in reality they were actually 40% wrong at the time. And so you can see people are overconfident and in reality they really shouldn't be because usually we're not really that correct. We make a lot of mistakes. And there are certain principles that scientists need to follow, and the scientific attitude is one of them. And so there's three. The first one is curiosity, right? They need to be curious. They need to ask the right questions. They need to, first of all, start asking questions. And they need humility. They need to understand, people make mistakes and we don't know everything. We are bound to be wrong in certain situations. And then we have critical thinking, right? People need to be able to problem solve. They need to think in a way where they are able to, um, they need to be able to make solutions. They need to think of very solutions very fast and very creatively. And then we have the scientific method. And the scientific method is a systematic way of gathering data so that biases and errors are reduced. Um, since we make so many mistakes, we need to have a formula in order to cut down on that. And in order to start any experiments, any methods, we need to have a hypothesis. So a hypothesis is a statement about relationships between variables. And soon, if your research is correct, it can soon develop into a theory. And a theory is an explanation that organizes observations and tries to predict outcomes, and that is established after repeated verification. So you need to have replicated your experiment multiple times in multiple different similar situations. And then we have operational definition. So operational definition is a statement of procedure that is measurable and allows for replication. And that means that we need to be able to define something with a numerical value. And often that that something is abstract. You can't really place a number on it. So then comes operational definition, where we need to be able to place a number. And following operational definition, we have replication. So that is the ability to repeat the experiment and hopefully get similar results. And if the experiment is replicable, that means that the initial results is more reliable. And in order to be able to replicate something, we need to have an operational definition, right? We need to have that foundation of where to start measuring. So an example, right? So how do we measure intelligence? Because intelligence is a abstract concept. There's no right or wrong. It's not black and white. We need to have, we, intelligence varies. There's street smart and there's book smart, and it just really depends on how you measure it. So when it comes to experiments, we need to have a operational definition in order to um, have a procedure based on it. So how would you measure intelligence? It could be based off of the SAT. It can be based off of a test, right? It can be anything as long as there is a number value to the operational definition of intelligence. And another one, and another example would be the concept of old, right? What do you determine is old? Is it perhaps, above the age of 40, or is it above the age of 50? So when it comes to experiments, we need to have an operational definition. And in this case, perhaps you have to find a certain age to take in subjects, and they have to be old. Then what would old be? So those are questions you need to answer, and you need to have an operational definition of. So let's move on to methods of research. So there are three main methods of research. There's descriptive, correlational, and experimental. And then within description, we have descriptive, we have case study, survey, and naturalistic observation. Okay, and then the first one is descriptive research. So the purpose of descriptive research is to objectively and systematically draw conclusions about why people behave the way they do. And the first type of descriptive research is case studies. So case studies studying one person or a control group. So that would be a smaller group. It wouldn't be like 50. It would be a very small group, in order to reveal universal principles. And the advantages of case studies is that it's more in depth, right? Because you're only focusing on a small amount of people or person, and it is detailed, and you have the opportunity to study more unusual cases, and it can lead to further study. If there's a interesting point that is discovered among a certain person, they can go on and research further about that specific subject. And then the disadvantages is that it cannot be generalized. It is prone to inaccuracies, and it is time and money consuming. And examples of case studies would be if you're trying to if usually it is involving like unusual cases. So an example of an unusual case is the study of Jeannie. So Jeannie was this child who was um, starved of communication. She was never taught how to speak. No one ever spoke to her. And so growing up, she was never exposed to any form of communication. So she lacked that ability. And so she was a very unusual case. So a lot of researchers, a lot of scientists, they, they saw this strange case, and they did a case study on her, because it was something that, that wasn't really touched on. And it was just also, you can't really do that to a person on purpose. And unfortunately, Jeannie grew up in an abusive household. So she was starved of this very, very important human necessity. And then we have survey. So survey involves collecting information through questions sent to multiple people. So when I say multiple people, that is going to be a fairly large group, and it estimates the attitudes and behaviors of the whole population. So when they collect information, the information should be able to reflect a certain group in a certain population. And the advantages of surveys is that it is often inexpensive, it reaches a large population, and it is mostly reliable. And the disadvantages are that it is not as in-depth, right? You can't really study a specific person or a specific group. And you also have to make sure that you are doing random sampling. So random sampling is a sample that must represent the whole population. So you can't cherry pick a specific group of people. It must come at random. And then we have courtesy bias. So participants might answer in a way where they think the interviewer wants to hear, and they could, so this means that they could be lying, they could be altering the truth in a way where it would not represent a whole population. And then we also have the wording effect. So word choice is very important because it can affect participant answers, can affect how they think, how they interpret the question. So you always have to word your questions in a way where it is the most it is, it's not like, uh, it's not, what's it called? It's not leading them on. And then we have naturalistic observation. So naturalistic observation involves observing and recording behavior in a naturally occurring environment, which means that there is no intervention and you're often just watching. And the advantages involving naturalistic observation is that it provides data and the behavior is not altered because you are watching from afar, and is very natural. And the disadvantages is that description does not always equal explanation. You can't go up and ask, well, why did you do that? Why did you say this? Why did you say that? Why did you, do this? You have to watch them from afar or else they will know. And and you also have to be careful when you're observing in general because there's observer bias. People see what they want to see. Um, you can't so people see what they want to see. They can, sometimes certain observers might the results to be a certain way, so they might just look away, and that is very easy to do. And that is a disadvantage that is very likely to happen. Another one is observer expectancy effect. So people often act differently when they know they are being watched. It's kind of just human nature to make to uh, act a certain way. Oh, and an example of naturalistic observation is Jane Goodall. If you guys have heard of her, she's a very famous researcher, and she did a naturalistic observation on chimpanzees, and she watched them in their naturally occurring environment, um, and watched them act and watch them kind of live their most natural way and not how they would act in a zoo, for example. And then we have correlation. So the purpose of correlation is to show if there is a relationship between two variables. So this is very much based on statistics and there's a lot of math involved. And correlational research, one of the most important things is correlation coefficient. So that measures the relationship between two variables, and that is measured by the value R. And that is on a scale of 1.0 to negative 1.0. And 1.0 is related to positive correlation. So as one variable increases or decreases, so does the other. So an example of positive correlation would be clouds and rain. The higher chance of clouds means that there is a higher chance of rain, right? So as the variable of clouds increase, so does rain. And then we have negative correlation. So as one variable increases or decreases, the other does the opposite. So for example, one example can be studying and bad grades, right? So if studying is one variable, as studying increases, the variable of bad grades might decrease. So, and that is the same if you switch it around. If studying decreases, bad grades might increase. So that is a negative correlation. And you can see on the right, there is there's some graphs. So as you can see, the closer the closer the variables are to the line of best fit, that means that there's a very strong positive correlation. If the variables are not as close to the line of best fit, that means that it's a fairly weak correlation. And that is the same with positive and with the negative correlations. And if the variables are just so scattered that you can't really place a line of best fit, that means that there are no correlation, and that is going to be measured by 0. So if a scale between two variables is negative zero point 0.8, so if R is negative zero point 0.8 on the scale of 1.0 to negative 1.0, negative negative zero point 0.8 would be a very high negative correlation, because first of all, negative zero point 0.8 is negative, therefore it is negative, it has a negative correlation. And since it is 0 0.8, it is closer to negative 1.0 than it is to 0. So that would mean it is a very high negative correlation. If the scale between two variables is 0 0.23, that means that it is a positive correlation, as it is going towards 1.0 instead of negative 1.0. However, it is a weak positive correlation because it is closer, it is still, however, it's still closer to 0 compared to 1. So that is so 0.23 is a weak positive correlation. So now why don't you guys give it a try? So can you guys give one example of positive correlation and then one example of negative correlation? And you guys can put that in your comments on Zoom. So like I mentioned, so an example of positive correlation would be um, the clouds and rain, right? So the higher the higher clouds are, the higher the rain is. And then negative correlation would be studying in bad grades. And why don't you guys privately message that to Kaylin, since she is here as well and she can take a look at those. Okay, so before we move on, does anyone have any questions? All right, so more onto correlational research. So everything is measured on a scatter plot. So that's the graph that you saw earlier. So A scatter plot is a graph of plotted points that show the relationship between two variables. And one of the most important things that that's very much emphasized when you're taking when you're taking a psych course is that correlation does not prove causation, because people often believe that positive correlation means that one variable may result in another. And one of the most infamous examples happened in the past, and I gave you this question: is ice cream dangerous? And usually you would say no, but back in 1952, you would say yes, because ice cream causes polio. And this was one of the biggest fails that that happened in science back in the mid 1900s. So during the polio epidemic, so while that was on the rise, scientists couldn't figure out why. They didn't know what the cause of polio was, and it was rising and it was affecting children everywhere. And researchers, they had to pinpoint a cause soon, and soon enough they found the culprit, and they declared that ice cream caused polio because they noticed a very high positive correlation between ice cream sales and children who contracted polio. And you can see on the graph to the right that the polio rates and the ice cream sale rates were very, very similar. They were rising and falling at the same exact times. And so scientists came to the conclusion, however, that was not correct. Polio was actually caused by poor sanitation, since back then they weren't very hygienic, I guess. And it rose during the summer times, as disease usually do. And then continuing on, there is a illusory correlation. So that is when a perceived correlation does not actually exist. So this is one of the many errors that humans make. And it is often influenced by confirmation bias. We tend to look for information that confirms our beliefs and ignores contradictory evidence. And it can often lead to illusory correlation. And and that usually happens when you're not actually looking at a graph, you're just kind of assuming at one point. Okay, and then we have experimental research. So the purpose of experimental research is to show cause and effect between variables. So as you can see, there was correlational research. Now we're trying to figure out why. So that is a procedure. So an experimental research is a procedure based on a hypothesis that shows cause and effect. So um, one thing that in order to do an experimental research, we need to have random selection. So that is when subjects are chosen at random from a large population, and um, because it needs to be able to represent the population, so it needs to be chosen at random. And then within that random selection, we have random assignment. So then the randomly selected subjects are placed in a control or an experimental group at random. And we also have independent and dependent variable. The independent variable is the variable that the researcher manipulates, and the dependent variable is the variable that the researcher measures. Okay, and then within experimental research, we have a blind procedure. So blind procedures are when the subject is unaware of certain information that may lead to conscious or subconscious bias that would invalidate the results. So they might not know if they are in um, a control group or if they're in an experimental group. And then we also have double blind procedure, and this is where both the test subject and the tester is unaware of which group the subject belongs to. And this cuts down on biases. Both of those do, but double blind procedure is even more strict. And this helps prevent the placebo effect. And the placebo effect is a measurable, observable, or felt improvement in health that is not attributed to treatment. And so, for example, the double-blind procedure and the blind procedure, they're often utilized in drug testing. So when they're testing a certain drug, they want to make sure that the subject does not know where they're in because of the placebo effect. often in the past, if there was a certain pill that perhaps stops headaches, they want to make sure that it actually works. So if there wasn't a control group where they weren't given a placebo, um, there's a chance where the pill wouldn't work. However, because the human mind is so powerful, the placebo effect takes in place and can result in um, them uh, like believing it so much where they stop having these headaches. Their minds just kind of take an effect. They're like, okay, well, if it's supposed to stop headaches, I guess it'll just stop headaches. And so while the pill may not work, your brain takes over. Your mind takes over. And so the control group is often given the placebo, and the experimental group is often given the actual pill. Any questions? All right. So let's move on to some statistics. So we have the measures of central tendency. So that is mode, mean, and median. So mode is the number that appears the most frequently. Mean is the average number, and median is the middle number listed from lowest to highest. Okay, and then on to our last topic, ethics. So when we do research and when we do experiments, there are often boundaries that we can't cross because we can't do that to another human being. And the American Psychological Association has 4 rules regarding human experimentation. So first of all, you have to obtain informed consent. So they need to know what they're getting into. However, you can lie within reason. And that is if you are have to experiment where if you tell the test subject it might affect how they react, and then um, and then but if you were perhaps doing a drug experiment, you uh, if you were doing a drug experiment, you might you probably most likely have to tell them because they need to know what they're actually putting in their body, right? So there are certain boundaries where you can cross and some you can't. And then you also have to protect them from harm or discomfort. So that is also within reason, as well as harm is a subjective concept. Sometimes during psychological experiments, you might have to put them in some sort of discomfort, and then you have to treat information of the subject with confidentiality. You can't just start talking about a certain test subject without just to a random stranger. You can't just talk about them when you're relaxing at home. And then you have to fully explain research afterwards. So you can't. After your research, you have to tell them exactly what happened exactly what happened to them, and they have to know like what they were looking for, what they were what the procedure was. So this is when you actually, if you had to lie in order to obtain informed consent, this is where you would actually explain what happened. All right, so that is it for today. Next week, we will be talking about the biological basis of behavior. So this would be where we talk about how the brain functions and hormones and things like that. And then our assignment, which descriptive research should be used, and that has been uploaded already. So you can take a look at that after. Okay. All right, so all right, you're all set. So you guys can leave. If you have any questions, you can leave. Yep. If any questions, you can stay after.